The James Webb Telescope reveals Orion's hidden heart. Unprecedented detail in this stellar nursery. Imagine gliding through space, approaching a vast, luminous cloud. The Orion Nebula, birthplace of stars. Up close, it's a swirling cauldron of gas and dust, glowing with newborn suns. Bright young stars carve out a vast cavity, illuminating intricate structures. Every star and planet, even our sun and Earth, was born in a place like this. Their birth sets the nebula ablaze, creating one of the galaxy's most spectacular sights.
What is a nebula? The word means cloud, but this is no ordinary cloud. A nebula is an interstellar cloud of dust, hydrogen, helium, and other gases, the building blocks of the universe. Some nebulae are remnants of dead stars, others, like Orion, are stellar nurseries. Here, gravity pulls material together to form new stars and planets. The Orion Nebula is special, just 1,344 light-years away. It's the closest massive star-forming region to Earth. You can spot it with the naked eye, below Orion's belt, as the middle star in his sword. Through binoculars, that fuzzy patch becomes a ghostly glow, a hint of the nebula's true grandeur. Its size is staggering, about 24 light-years across, with enough gas and dust to form thousands of suns. The nebula is a bustling city of stellar creation, filled with raw materials and powered by its brightest residents. It's not a uniform cloud, but a complex tapestry of filaments, sheets, and dense clumps, all interacting in a cosmic dance. Early astronomers saw it as a nebulous star, but spectroscopy revealed its light comes from glowing gas, not a single star. This discovery changed everything. Space between stars isn't empty, but filled with the stuff of creation. The Orion Nebula became a key to understanding the cosmos. It's a living example of the cycle of birth, life, and death in the universe. By studying it, we learn how stars and planets, including our own, come to be. The Orion Nebula is a cosmic laboratory, revealing the secrets of our origins. Our fascination with the Orion Nebula has driven us to build ever more powerful eyes to study it. Early telescopes revealed its cloudy nature, but the first photograph in 1880 captured details the eye could never see. Earth's atmosphere blurs our view, so we had to go to space. The Hubble Space Telescope changed everything, giving us breathtakingly sharp images of Orion's heart. Hubble revealed newborn stars, glowing gas, and intricate structures, front-row seats to cosmic creation. But visible light is blocked by dust. To see deeper, we needed infrared. Enter the James Webb Space Telescope, designed to pierce the nebula's dusty veil. Webb's infrared vision reveals hidden stellar infants, still wrapped in their cocoons. Where Hubble saw glowing gas, Webb sees the filaments and knots forming the next generation of stars. Hubble and Webb work together. Hubble shows the nebula's surface in visible light, while Webb reveals the hidden processes inside. Together they provide a complete, multi-wavelength view of this stellar nursery. We can now piece together the entire story, from dark clouds to shining stars. Each new image brings us closer to understanding how stars and planets are born. The Orion Nebula is no longer just a beautiful object, it's a window into our cosmic origins. Our telescopes have turned a fuzzy patch in the sky into a living, evolving story of creation. At the heart of the Orion Nebula lies the Trapezium Cluster, a brilliant group of young stars. These cosmic newborns, less than 1,000,000 years old, are the nebula's engine room. The four brightest form a trapezoid, but they're not ordinary stars. They're O and B-type titans, far hotter and more massive than our Sun. The most massive, Theta 1 Orionis C, is about 40 times the Sun's mass and hundreds of thousands of times brighter. Their ultraviolet radiation carves out the nebula's cavity, making the gas glow. Fierce, stellar winds from these stars create shock waves, sculpting the nebula's intricate structures. Their radiation and winds erode the cloud, but also trigger new star formation. These giants live fast and die young, ending in supernovae that enrich space with elements needed for planets and life. The trapezium stars illuminate and seed the galaxy with the raw materials for future generations. Deep within Orion, Hubble and Webb have revealed the birth of solar systems. Young stars are surrounded by protoplanetary disks, proplyds, cosmic leftovers from star formation. These disks are the raw material for planets, moons, and comets. Gravity collapses a clump of gas and dust, spinning it into a disk around a growing star. Inside, tiny dust grains stick together, growing from microscopic particles to planetesimals, the building blocks of planets. Through countless collisions, some planetesimals become full-fledged planets. But these fledgling systems face danger. Intense radiation and stellar winds from the trapezium threaten to strip away their disks. It's a race against time. Can planets form before the disk evaporates? Orion shows us that planet formation can happen even in extreme environments. By studying proplyds, we witness a process that shaped our own solar system 4.6 billion years ago. We are watching our own origin story unfold. The nebula is a cosmic nursery, where new worlds are sculpted by the laws of physics. Each proplyid is a potential solar system, a testament to the universe's creativity. Orion's disks remind us that the birth of planets is a universal story. Imagine landing on a young, rocky planet orbiting a sun-like star deep within Orion. The sky would never be truly dark, perpetual twilight, painted with the nebula's vibrant colors. Curtains of red, green, and violet would stretch across the sky, shifting like a cosmic aurora. The trapezium stars would shine as dazzling jewels, their brilliance dwarfing our sun. Fierce ultraviolet light would make the surface uninhabitable without a thick atmosphere and strong magnetic field. The nebula's glow would wash out distant stars, creating a sense of enclosure within a cosmic womb. The environment is dynamic, currents and flows, dust filaments drifting across the luminous background. Temperatures would swing wildly, from frigid shadows to scorching gas exposed to the trapezium. Life here would need to be incredibly resilient, adapted to high radiation and a sky that never sleeps. It's a world both beautiful and hostile, a testament to the extremes of our universe. The Orion Nebula isn't just a peaceful nursery, it's a place of cosmic violence. Hubble discovered fast-moving clumps of gas, Orion bullets, 10 times the size of our solar system, racing at 250 miles per second. These bullets plow through hydrogen gas, leaving glowing wakes from the heat of collision. They likely resulted from a cataclysmic event involving massive protostars, blasting gas out in all directions. Related are Herbig-Haro objects, bright patches formed when jets from newborn stars slam into surrounding gas, creating shock waves. These jets act as release valves, allowing more material to fall onto the star. Herbig-Haro objects are signposts of star birth, revealing hidden young stars. The nebula's violence is a crucial part of the star formation process. The Orion Nebula is just one bright window in a vast structure, the Orion Molecular Cloud Complex. This colossal region stretches hundreds of light years, with enough material to form hundreds of thousands of suns. Most of the cloud is dark and cold, hiding star formation within. The nebula is simply the part lit up by the trapezium cluster. The complex includes other landmarks: Barnard's Loop, a supernova remnant, the Horsehead Nebula, a dark cloud forming new stars, and the Flame Nebula, another emission nebula. It's a cosmic ecosystem. Death of one generation triggers the birth of the next. Studying the complex gives us a broader view of star formation, from dark clouds to blazing nebulae. We see the full cycle: quiet beginnings, brilliant births, and explosive ends. The Orion complex is a storybook of stellar evolution, shaping our galaxy. Star formation here is a large-scale, ongoing process that sculpts the Milky Way. The Orion Nebula is a fleeting phenomenon. The very stars that light it up are destroying it. In about 100,000 years, most of the gas and dust will be blown away, leaving a young cluster of stars. Over millions of years, these stars will drift apart, mingling with the Milky Way's vast population. Our sun was likely born in such a cluster. This makes our chance to study Orion precious. We're living in a privileged moment. Each new discovery adds to our understanding of how galaxies, stars, and planets form. The elements forged here are the same that make up our world and ourselves. The Orion Nebula is a glowing beacon, inspiring our endless quest to understand the cosmos.